Okay, so this is the review for chapter 4. So it's only covering 3 sections. This is just part A of the review because the test is only over the first 3 sections of chapter 4. So when you're having a function like this, the first thing you might want to do is just plot the zeros, right? So you get a 0 at -2, +1, and +2. So 2, 1, and -2. So plot my zeros. You might want to think about end behavior. So for this one, that would be x to the 3rd power. So you have a positive number to an odd power. So that is definitely going to be down, up. So from the rightmost point, it's going up. From the leftmost point, it's going down. Got that kind of a look to it. It looks like here the y-intercept would be really helpful to have. So I'm going to plug in x equals 0. So when x equals 0, let's see, that would be 2. Y would equal 0 plus 2 is 2. 0 minus 1 is -1. And that's -2. So that's +2 times 2, which is 4. There's a y-intercept at 4. That helps me out a ton. In fact, I can probably just draw my graph at this point. By the way, all of these were the first power. All these vectors have a multiplicity of 1. So I knew none of these were going to bounce. They were all going to go through the axis. It goes through the x-axis, goes through, goes through. That's probably good enough for that sketch. It's more of a sketch than an actual graph. I could plug in maybe a point at 1.5 just to see how low that goes. For an x value, I would consider that, but they're so close, I'd probably just leave the sketch like that. That's a pretty good sketch, which is what we want for this, right? So now we have a 0 at 0. If you set that equal to 0 and solve, I think you get -3/2, and you get 1. So just set that equal to 0 and solve it. So -1.5, I'm sorry. Whoops, let me try to, there we go. -1.5 is right, oh, it's right there. That's nice. 0 and 1 is right there. Okay, so they're kind of spaced out. I did the graph a little bit different just so they would be a little bit more spaced out there, which is nice. The end behavior, if you multiplied -x² times 2x times x, I think you get -2 x to the 4th as your first term. Don't worry about the rest. So that determines end behavior. So it's going to be negative and even. So that is definitely down, down. So from here it goes down from the leftmost point and from the rightmost point. It does, I don't need to find the y-intercept because I have that basically. It is going to bounce at this at 0. So it's going to go through here, and then it's going to bounce here and then bounce back up. It's going to look something like that. I think this is one where I probably need to plug in a point or two just to make sure I have a little more accurate graph. So I think maybe -1 would be a good value to plug in. So if x equals -1, that would be -1 squared times 2 times -1 plus 3 times, I'm trying to run around -1 minus 1. So that would be -1 times, this is -2 plus 3 is 1. -1 minus 1 is -2. So that's going to be a positive 2, it looks like. So if I plug in -1, I get a +2. So it does go through that point right about there. Okay, so this one, you might see a little factoring. You can do x plus 1, x minus 1, difference of squares there. So you have solutions at 1, -1, and 2. 2 minus 2 is 0 if you set the equal 0. So 2, 1, and -1. They're all to the first power, so it's not going to go through here. End behavior in this one would be x to the 3rd. So let's see, that's positive and odd. That would be down, up. So from the leftmost point, it goes down. From the rightmost point, it goes up. The y-intercept looks like it'd be really good to do here. So when x equals 0, plug in x equals 0 here, and you get y equals, was that 2 minus 0? So 2 times 0 minus 1 is -1, so -2. So I get this value. That helps me a ton right there, right? So it's going to bounce off. Something's wrong here. What do we do wrong? Okay, so be really careful about this. Negative x, I figured out what I did. So negative x times x squared is actually a negative x to the third, which means oftentimes, by the way, if you make a mistake, you can catch your own mistake if you're using the rules that we've taught you here. So we have negative x cubed. So that is definitely going to be an up-down situation for end behavior. So on the left, it's going to be up. On the right, it's going to be down. Because I was like, I knew it wasn't going to bounce. How is that going to work? The y-intercept, we did correctly calculate as -2 when you plug in 0 for x, so -2. So the graph's going to look something roughly like this. And that's a pretty good graph of it. And this one, set the factors equal to 0, you get -4, you get 0, so 0 and -4. Oh, wow. Did not do this. Okay, so I'm going to change the scales here. So we're going to make each one of those 1 rather than every other one. So I'm going to make this 1, 2, 3. That's going to be -4 right there if you follow. I think that would be a better move here. So that's -4. This would be -1/4. So okay, so let's see. End behavior is going to be negative. So we have -1/4 x squared would be the first term. So that's going to definitely be down, down. So from the rightmost point, it's going down. From the leftmost point, it's going down. And both factors for the first power, so it's definitely going to go, up there in the middle. It's going to look kind of like that, like a parabola. But I want to know how far up, so I'm going to plug in a -2 here. So if x equals -2, let's see what we get. So we get y equals -1/4 times -2 times -2 plus 4 is +2. So we get -4 times -1/4 is a +4/4, which is 1. So we get y equals 1. So I think it'll be about there. If that's 1, I just kept the y-axis the same. That's 1 right there. And you got it. Determine the end behavior. So look at the term with the largest degree. This is going to be up, down. Largest degree. This is going to be down, down. Those are quick, right? If you know what you're doing, you know the 4 cases. Graph them using your TI-Nspire. So x to the 4th minus 18x squared plus 32. Wow, there's a lot going on with that one. Looks like I might need a much larger y max. So I'm going to say like 75, -50. I don't know. Ooh, I want to make that more. -75. That would be perfect, maybe. Okay. You don't have to resize the window. It's just kind of handy to do that. So it's up to you if you want to resize the window or not. So go to menu, graph trace. I'm going to find that minimum right there. I like to press enter to lay down a point. It should say maximum unless the y-intercept is also the maximum, which it looks like it is. And then the minimum would be there. So find the minimums, and so you would just write down the ordered pairs there. The minimums would be at the relative minimums or the local minimums. And 3, -49. And then the max, the local max or the relative max would be at 0.32. And you do that same thing for the next function here. So go to the graph page, down key at -2 x to the 3rd plus 10x plus 3. You don't have to change it so you can see it, but I like to do that. So I'm going to say 30 and -20 so I can see the function really well. Lots of times you end up only adjusting the y values. It's kind of interesting that many times is the case. So this time I go menu 5.1. Oops, I guess I'll do that. Maximum is right there. Minimum's right there. This is a really easy scale, right? So max at 1.29, comma 11.6, and min at negative 1.29. That's interesting. 0.29, comma negative 5.61. Okay, so now we need to find the min or max value with no calculator. Okay, so we're going to try to find the stuff with no calculator. So I'm going to use the H method here. So H equals the opposite of B over 2A. So the opposite of 6 over 2 times negative 1 would be, that's a negative, negative, so positive 3. So H is 3. So K, we're going to find by plugging in. So negative 3 squared plus 6 times 3 plus 3. So we get negative 9 plus 18 plus 3. 21 minus 9 is 12, I believe. It's 9 plus 3 is 12. Okay, so K is 12. So find the min or max. So this function is definitely opening down. The end behavior is down, down. So this is going to be a max point. So the max value will equal the K value, which is 12. So max value is 12. So I'm not looking for the maximum minimum point here like we were in the last problem, but the actual value, which is the K value. This one, again, H equals opposite B over 2A is, let's see, 8 over 4 is 2, but that's going to be negative 2. So now we're going to plug in everywhere there's a 2 for our K value. It's going to be negative 2 squared in parentheses plus 8 times negative 2 minus 2. So that's 2 times 4 is 8 minus 16 minus 2. 8 minus 18 is negative 10 is K, which means this is going to be, by the way, because it's opening up, because A is positive, this is going to be a minimum value. So the min value is K, which is negative 10. That's as low as the graph goes for this parabola. Complete the square, so this is fun. This is just a little different version. We move the constant over first. You're going to add 2 to both sides. You get y plus 2 equals x squared plus 8x plus blank. We're going to add that same amount to both sides. Half of 8 is 4. 4 squared is 16, so we're going to add 16. So we get y plus 18 equals, that should be a perfect square, x plus 4. It's always just a square root of that guy goes there. That's plus and plus, so it's plus. Subtract 18, and that's squared, by the way. So you get y equals x plus 4 quantity squared minus 18. If they asked you, what's the vertex, you would say negative 4, comma, negative 18 is your h and k. That was not part of the question. Okay, this is a little tougher now. Move the constant over first, add 1 to both sides. Y plus 1 equals negative 2 x squared plus 10x. So in this context, we want to pull out that, not the GCF, but just the a value. So we're going to factor that out. So y plus 1 equals negative 2 times x squared. I guess it would be minus 5x plus blank plus blank. So, oh wow, this is not fun. So half of 5 squared, so that'd be 5 halves squared. I know it's negative, but it's going to be squared, so it's going to be 25 fourths. So I add 25 fourths, but I really didn't add 25 fourths. What did I effectively do? Because it's being multiplied by negative 2. I really subtracted negative 25 halves. So I'm going to subtract negative 25 over 2 from that side. Kind of even it out. So 2 over 2 plus negative 25 over 2, it's going to be y. Wow, this is not fun. 23 over 2 equals negative 2. This should be a perfect square. The square root of 25 fourths is that. Last step, move it over. Y equals -2 times x minus 5/2 squared plus 23 over 2. If you ask for the vertex, it would be positive 5/2 comma 23 over 2. Getting there. Okay, graph the quadratic. The reason I left a little room there is you might want to use your HK method to maybe get the vertex here. So I'm going to try that. So H equals opposite B over 2A. So that'd be 4 over 2 times 1, which is 2. So K is going to be, I'm going to plug that in. So everywhere there's an X, I'm going to plug in a 2 there. So it'd be 4 minus 8 plus 1. That's 5 minus 8 is -3. So K is -3. So my vertex is at 2 comma -3. So now I think I can probably graph this. 2, -3 is right here. The A value is 1, which means this is a pretty normal parabola. It's going to go over 1, up 1, over 2, up 1, 2, 3, 4, over 2, up 1, 2, 3, 4. Axis symmetry, the equation is x equals 2, if that was asked, I'm not sure. And you got your problem. Let's look at this one. Again, let's use the opposite of B over 2A method. So H equals 8 over 2 times -2, which is 8 over -4 is -2. So K equals -2 times -2 squared, minus 8 times -2 minus 3. Hopefully this works. I don't know if I planned this. Okay, so -2 times 4 is -8 plus 16 minus 3. So that's -11 plus 16 is positive 5. Barely fit if I remake the axis. I have to do that again. Okay, so the vertex is at -2 comma 5. So for this one, I am pretending that these are just 1 stuff. In fact, I'm just going to erase these also. So sorry, any of those points are not really, like, we're just going 1 unit at a time for this, not what that had. So -2, 5 is -2, 5, 1, 2, 3, 4, 5, right there. And A is -2. Okay, so that means it's opening down. Instead of going over 1, down 1, it's going to go over 1, down 2, over 1, down 2. So you're going over 2, down 4, 2, 3, 4 is going to go over 2, down 8. That's 8 right there. Over 2, down 1, 2, 3, 4, 5, 6, 7, 8. Symmetric with that one. So your points are right about there and there. I know there's a lot of extra little points there. The axis of symmetry is x equals -2. Find the quotient and remainder using long division. So let's just try this one. So we've got 2x squared minus x plus 2. And we've got 8x to the 4th plus 0x to the 3rd plus 6x squared minus 3x plus 1. Notice I put in the x cubed term because there was no x term, cubed term. So 2 times what is 8? That'd be 4x squared here. So 4x squared, 8x to the 4th. Minus 4 times negative x is minus 4x to the 3rd. And then plus 8x squared. But I'm subtracting everything there. So that's going to be subtracted, added, subtracted. So that's going to be positive 4x to the 3rd minus 2x squared. Bring down the next term, minus 3x. That's an x there. 2 times 2 is that, so plus 2x. That's a 2 there. 4x cubed minus 2x squared minus, sorry, plus 4x, I think. Yeah, plus times plus, okay. So we subtract that, which means I'm going to subtract each term. Okay, so that's interesting. This goes away, this goes away. So this is going to be negative 7x, bring down the next term, plus 1. I think I'm done. That doesn't go into that, so that's my remainder. So my answer, my quotient is 4x squared plus 2x plus a fraction, negative 7x plus 1, which is my remainder, divided by my divisor, which is 2x squared minus x plus 2. Okay, another long division problem here. So we've got 3x to the third minus 12x squared minus 9x plus 1. So x times what is 3x? So that'd be 3x squared positive. So we get 3x to the third minus 15x squared. Subtract that, which means everything changes. This would be 3x squared minus 9x. Just bring down the next term. This would be plus 3x, I guess. So 3x squared minus 15x, but don't forget we're subtracting both those. So it's going to end up being a positive 6x, bring down the next term. X times 1 is 6, so that's plus 6. I know I'm done up there. 6x minus 30. Subtract both those. So you get 31 as your remainder. So my answer is 3x squared plus 3x plus 6 plus 31 over x minus 5. Synthetic division now. So in the box is going to be a 5 here. And we have the 3, negative 12, negative 9. There's no missing terms there. That's nice. 3, 15, 3, 15, 6, 30, 31. Remainder. This is x. This is x squared. That's a lot like this answer we just got because it's the same problem. We just did a different method. So our answer is 3x squared plus 3x plus 6 plus 31 over x minus 5, which is divisor. Here we're going to put negative 2 in the box. 4, negative 6, 0, negative 3. Don't forget about that 0. Negative 8. Ooh, this doesn't work out well, does it? Negative 14. Positive 28. 28 times 2 is negative 2 is negative 56. Wow. Negative 53 is the remainder. This is x squared. So we get 4x squared minus 14x plus 28, so 2, minus 53 over x plus 2. Negative 1, 1, negative 1, 1, 6. Oh, this is going to go fast. 1, this is negative 1, negative 2. If I add, it's going to be 2, which is 3, negative 3, 3. My answer is 3. The remainder is the answer when you do synthetic substitution. In other words, p of negative 1 is equal to 3. If I plugged in negative 1, I get negative 1 minus 1, which is negative 2, minus 1, I'm trying to do this in my head, is negative 3, plus 6 is 3. We get the same answer. Plug it in the old-fashioned way, but it's so much fun doing this synthetic substitution. So 2, 3, negative 4, 5. I didn't have any missing terms, so these were a little bit easier. So negative 4, negative 1, 2, negative 2, 4, 9. So 9 is my answer on this one. So the question would be, what is p of negative 2? The answer is 9. I think this might be the last problem. Wow, we're already there. Okay, so just time flies when you're having fun here. So p is degree 3. So you got the 0. So your function is going to be, you could say y equals or f of x. You've got 3 factors because it's degree 3. One of them is going to be x minus 2 because of that. One of them is going to be x minus 3 because of that. 1 is going to be x plus 1 because of the negative 1 there. I would just FOIL these guys together maybe to start. This would be x squared minus 2x minus 3x is minus 5x plus 6 times x plus 1. And then FOIL that together. We'll clam it however you want to talk about it. So you're going to get x times x squared times x is x to the third. X squared times 1 is plus x squared. Negative 5x times x is negative 5x squared. Negative 5x times 1 is negative 5x. 6 times x is plus 6x. And 6 times 1 is plus 6. See if this works. So x cubed minus 4x squared plus x plus 6 is what happens if we multiply that out. Well, I guess it's the whole function, right? It'd be y equals, don't forget f of x or y equals or something. And you've got it. That's the end of the review.